How do you identify that a particular problem is non-recursive? For a non-recursive set, there is no general algorithmic way of deciding whether or not an element belongs to that set. There are many problems in mathematics that are considered non-recursive. That is why we might have a class of problems to which the answer in each case is either yes or no, but for which no general algorithm exists for deciding which of these is actually the case. Let us consider the example of a problem, that is, the word problem. Roger, in his book, The Emperor's New Mind, describes the problem as: suppose that we have some alphabet of symbols and we consider various strings of these symbols, referred to as words. The words need not in themselves have any meaning, but we shall be given a certain finite list of equalities between them, which we are allowed to use in order to drive further such equalities. This is done by making substitutions of words from our initial list into other normally longer words which contain them as portions. Each such portion may be replaced by another portion that is deemed to be equal to it according to the list. The problem is then to decide for some given pair of words whether or not they are equal according to these rules. Let us take the same example that Roger took in his book. Then our initial list is eat equals to at 8 equals to a later equals to low, pen equals to pillow carp equals to me. And from these initial lists, we can extract let equals to leap by doing multiple substitutions. But can you go from one word to another if we are given some words? So for example, can you go from carpet to meat? Or can you go from caterpillar to man? In the case of caterpillar to man, we can, but we cannot go from carpet to meat. To prove that we can go from one word to another, we only need to exhibit a string of equalities where each word is obtained from the preceding one by use of an allowed relation. And this is it. We have a clear algorithm to prove if two words are equal. But what if we need to prove that we cannot go from a particular word to some other word? That's somewhat tricky, and one has to resort to arguments about the rules that are given. One way to prove two words unequal is to check if the sums of numbers of A's, W's, and M's is equal. Because in every equality in our initial list, the number of A's plus the number of W's plus the number of M's should be same on each side. Thus, the total number of A's, W's, and M's cannot change throughout any succession of allowed substitutions. But there is no such obvious algorithm in general that can prove if words are not equal. We have to resort to intelligence to reach a conclusion. Thus, it turns out that there is no single algorithm that can be used universally for all possible choices of the initial list. In this sense, there is no algorithmic solution to the word problem, and that it also belongs to non-recursive mathematics.